Hello and welcome to NARC Live on Wednesday the 9th of October 2024. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G0KYA. Lovely to see you. On tonight's show, our special guest is Steve G0KYA with his presentation on MMANA-GAL antenna analyzer software. We've got club news and views, including pictures from recent events. And we find out what on earth this is. And we have had quite a few entries, but if you haven't entered and you think you know what that is, you can drop it onto BATC or Facebook and we'll read it out with the other entries. Firstly, some sad news for some of you who may not already know, but we announced last Wednesday at the NARC meeting at CNS that long-term member of NARC, Chris G0GGF, has sadly silent key. What we do have now are details of Chris's funeral, and here they are. And that was Chris. I know some of you more recent members may not know him, but that was Chris, a real character. I'm sure we all agree. He hadn't been well for the last few years, but anyway, these funeral details are there. I'll also be putting this on the newsletter, Friday the 1st of November at 2 o'clock, and hope lots of you will make it. If you are going to the wake afterwards, which is next door to the church, the reading room's next to the church, then please, if you could let me know. The family are just trying to get some idea of how many people to cater for, and we do expect quite a few radio chums to come. So if you could just drop me a note and just say, yep, I plan to go to the wake, then I can give the family some idea. So that's Friday the 1st of November, but it will be also on the newsletter. Now, some of you know, if you went to the Hamfest recently, the RSGB had a special offer on new members joining them. They had to be new members who hadn't been a member for the last year or more. And they had an offer where they were offering one of the Quansheng handheld radios. In fact, the very same one that we saw just 2 weeks ago when Tim gave his talk about VHF and UHF. One of the special things about this radio is that it's got lots of modifications and hacks for radio amateurs. I even saw one the other day, someone showed me that you can even put SSB receive and things on it, on this little tiny handheld transceiver rather. Anyway, they were giving them away there with brand new memberships, and they offered to extend it for NARC members for a very short time because they have some radios left. Now that offer is extended. Already 2 of you have signed up to become a member of the RSGB, but if you're watching this now and you're watching it before the end of this weekend coming up and you'd like to join the RSGB and you haven't been a member for at least 12 months, then if you let me know, drop me an email, I'll tell you how to go about applying for it and the special code that you quote, which will give you one of these free radios as well. I mean, the radios vary in price from sort of about £20 from a Chinese website to sort of £35–40 in the UK. But given that the RSGB membership is only just over £60, that's a real nice thing to have, and something, especially if you like tinkering and experimenting, because as well as the VHF and UHF, you can do a lot more with it. Anyway, we're happy to promote that for the RSGB. Of course, it is the society which represents our interests. Lots of us are volunteers, including Tammy and myself, for them. And I hope that's of interest to some of you who've not joined the RSGB recently. Just drop me an email basically and I'll tell you how to go about it. The other thing, while we're talking about RSGB, of course their big annual convention is this coming weekend at Milton Keynes, and the online booking in advance is now closed, but you will be able to buy tickets on the door. They're not going to be overfull or anything like that, so you could just turn up to Kent's Hill. If you want details of it, this is the address to look at. It's rsgb.org/convention. Now, one other thing I would mention, and again, I have put it in the newsletter, but if you haven't spotted it on local news, things like Look East and things, the A421, which is one of the main routes that you'd take normally going from Norfolk to there, has been hugely flooded in the rain that we had a few weeks ago. Now, the flooding is largely cleared, I believe. However, there is still a lot of restrictions on those roads. So the advice really before you travel is, if you do it the old school way, have a look at, say, the AA website and plot which roads you're going to go to. Or if you use something like Google Maps or Apple Maps or
other maps are available.
other maps. What's the other one we use? Waze and things like that. Then if you use a dynamic map like that, then of course that will help you get you there the best way. But do watch that if you're going that direction. Also, I should tell you that Tammy and Kevin and I will be there all the weekend, along with lots of other NARC members, but we'll be there to provide a live stream of many of the talks and some interviews and things like that. It's quite a busy time for us. We go there, in fact, on Friday morning first thing and set up a live stream studio there. So you'll be able to watch some of the talks and lots of other interviews and other interesting pieces over the weekend if you can't make it in person. And you do that just by going to the RSGB YouTube channel, or again, look at that link that's on the website now, rsgb.org/convention, and the links will be put up there once they're live. But it's both days, Saturday and Sunday. And finally, on the subject of the convention, because of the convention, lots of the people who would normally do the monthly Koblensked are going to the convention, so we've postponed that by a week, and now the Koblensked monthly Koblensked will be on Saturday the 19th of October, but I'll send you more details of that in the newsletter next week. Now on to members' news. Well, actually, to be honest, there hasn't been any news from any of you. Now, I'm sure you've had things happen in your life. We do like to hear them. We like to see funny pictures and that sort of thing. So just to get our own back and a few of you, of course, we did have a very nice trip to the Hamfest since we last met, and some of us took some pictures. So let's have a look at some of those pictures, Tammy. There we are. That's a picture I took from the front of the coach looking right to the back. This was like a carry-on film, didn't it? Really? It doesn't remind me of a carry-on film. There we are. And the next picture will show us this, which was really good. When we got quite near Newark, this was a beautiful rainbow that was in front of us. It covered, went from end to end. Another picture here. Daniel sent us this one. This is a view from the back. We can always tell the troublemakers because they were sitting at the back. Yeah. And this was a radio that was there, which is one of, I suppose, a few launches there, but this was a major one. This is the IC7760, which is the ICOM new, sort of one of their flagship radios. It looks really nice. It's about nearly £6,000, I think it's going to be. What was staggering, though, I thought, is this display unit near you is a remote head, so you can put that on your bench without taking much space. But that's fairly big. It's bigger than, say, an IC705 or a 7300. But look at the brute of the box next to it. That's got all of the radio gear in it. So it's really quite, it's let them have the freedom, I guess, to put loads and loads of electronics in. So if pounds per kilo of electronics they need to go by, it looks like you're going to get your money's worth there. But that was one of the brand new radios on show at the Hamfest. And one other picture we'd like to show you. We didn't take this picture because we didn't take this picture. And this is for Bob G7JTZ and on behalf of Paul G3VPT, because he's always having a go at him. And have a look at this.
It just all got too much for some people, didn't it?
Oh dear. Is Bob not going to talk to us now?
No, probably not.
We had to show that picture, Bob, though, because you do send similar pictures of your friend Paul. And anyway, there's a picture of me taken the other day, a sneaky picture of me asleep, so why shouldn't you? Shouldn't just be me for that. All right, Tammy, show us some little people. By the way, do try and send us some bits and pieces that we can use in the news before the next NARC Live. That'd be really good. Tammy.
Here's the little people. Ever wonder what happened to all those pocket watches?
Oh, yeah, love it. That is a good band. Yeah, good drum set. Miniature-calendar.com. New picture every day. And you pick one out for us. There's all your stopwatches and your pocket watches and stuff like that. That is really good, isn't it?
Not sure what kind of tune you get out of them, but...
The pressure on them to do a different picture every day as well. It's amazing.
I suspect maybe they do like the whole week's worth in one day, perhaps, or something, yeah.
But it's still a lot. It's a pressure, though, when they've been doing it for years, haven't they? How long have we been showing this for?
Well,
3 years?
Yeah,
more?
but they've been doing it for... I don't know, about, I can't remember if it's 10 or 15 years now. Wow. If you look back on their website, there's a lot. Anyway, thanks for choosing that for us, Tammy. So as I said, we really would love to hear from you with your news and pictures and things. Just even a funny picture. It doesn't have to be radio related. It just keeps everybody connected with the club. We'd love to hear from you. Now we're going to return to the competition, which we set 2 weeks ago. I thought this was pretty difficult, really. But I'm not sure that's what you thought. We will have to have a look and see if there's anybody who's entered this. But anyway, we did ask 2 weeks ago, what on earth is this? Da-da. I mean, that just could be
a hairdryer, or with those little pictures on the
Hairdryer?
right? Well, the pictures on the right, couldn't it? Or something like that.
Upside down.
Anyway, let's
hairdryer.
just see. Did anybody answer it on NARC Live, on BATC or Facebook? No, nobody's entered anything there. Well, actually, we did get a surprising number, I thought, of entries for this. So let's see if any of them were right. Steve, G0KYA, said, this week's object looks like the control panel from Stuart's road sweeper.
James M0ZAH, I believe this week's object is a control set for a road sweeper. I'm also going to guess that the originator of this image is Stuart M0JKB.
Okay. Ben, M7FRS, I believe the answer to this week's what on earth is this? Is the controls of a road sweeping machine.
Keith, M7KKO, higher is a road sweeper control for the brushes and jets.
Bob, G6PWS, by the bottom button, which looks like a beetle, I would say that this is a controller for a Scarab road sweeper. They also have a better model now with a joystick in the upper position, which gives control of the brushes, etc.
There you go. I lost where we are now. Martin, G6WNN, I think that this week's what on earth is the auxiliary control on a Scarab Maven 65 road sweeper. Bit quite specific.
Very. Nigel, G8IFF, stroke W8IFF, says it is the secondary controller from a street sweeping vehicle.
And Mike, M0NTZ, it's been a long time since I was a member, but I'm still on the mailing list, so I thought I'd have a go. Looks to me like the control panel of a road sweeper, possibly a Scarab. Vehicles in the background seem to suggest part of a fleet.
Wait, okay, vehicles in the background?
Well, you can sort of see maybe half a tyre.
Okay, Mike, your eye's better than mine, and I'm looking at this on a monitor here. Anyway, let's put you out of your misery. It may not be much of a surprise to learn that it
is a road sweeper control panel. Now, this actually, I think since Stuart took the original picture, they've actually had an upgrade, because it was quite a while ago. I think he sent the picture in. So this is actually the new control panel on the new one on the left. And he was telling me about all the images there. So you've got cameras on each side, so you can see what is happening.
But I'm staggered, and I know you can put pictures into Google and the like and find out what something's are, but that often happens with stock pictures. But this is a picture which Stuart sent us, the picture that he took of his daily work vehicle, and I'm amazed that this many people got it right.
And it is a Scarab.
And exactly, to get it to the level that is exactly the right model is amazing.
Yeah.
Anyway, thank you, Stuart M0JKB, for sending that in to us. I thought it would fox people, and I'm amazed, probably like you are, that so many people got this right. Well done to everybody who did. Who is I loved it. I mean, Bob, G6PWS's comments, they also have a better model now with a joystick in the upper position, which gives control of the brushes. I mean, how would you have known that so many people would be so well, educated to know that this is a road sweep control?
Well,
anyway, well done to all of you. Let's see how good you are with this one, though, because this is also coming from a member. And I'm going to ask you, what on earth is this? And maybe what on earth is it used in or for? I think this one's more tricky, but we'll see. Famous last words. I'd have said that about the other one.
I know what it looks like, but I know it's not right.
You mustn't say it.
No, it's not right what I think it was.
So what is this, or what's it used in or for? That's a kind of clue that it's part of something. I think it's reasonable to tell you that this is part of something. Okay, and it's used for something very specific. You've got just under 2 weeks to let us know. Answers, as usual, to radio@dcpmicro.com, and we'll reveal all in just under 2 weeks' time when we're back again. Good luck. We'll put that also on Facebook and on our newsletter as well. Now, before we come to tonight's talk, just time to look at what's happening at the club this week. As usual, on Sunday, obviously we've got the RSGB convention this weekend, not a club event, but many of you will be going to that. On Sunday, though, we've got the GB2RS News on GB3MB at 7 o'clock. On Monday at 7:30, the Monday Night Net, also on GB3MB. And then next Wednesday, a week from today, October the 16th, it's an informal social meeting at CNS. And of course, we've got that free show and share table as well, with lots of items that people bring. And I'm always amazed how many go. So if you're coming and you want to get rid of some bits and pieces, or you're coming and you just want to grab a few bits and pieces, then come along to next week at the CNS school. We'll be back here in 2 weeks' time. And of course, as I said, please do send us your pictures and your stories and everything to keep in touch with what you've been doing. And of course, this card, which we're always sending. We sent a card like this actually to Chris's wife, Judith, last week, but we're happy to send this to people to cheer them up or to mark an occasion or whatever. Just let us know your name and the address to where to send it, and we'll add our name to yours and send it to anybody at all. We'll be very happy to do that. So now on to our main event. Now this is something a bit unusual because way back in April, Steve G0KYA gave a talk at CNS on MMANA-GAL antenna analyzer software. And one of the reasons we did it at CNS, it was at a time when we were trying really to see whether you, our members and viewers, wanted to talks to be in person, whether they prefer them in person or whether they prefer them to be online. In fact, that evening, about the same number of people came that week as a week when we haven't got a talk or anything on, so it didn't really prove that that was necessary, and we normally have more people watch the talks online. However, we recorded it. We took the recording gear and Kevin, Tammy and I recorded the event, and we put it into stock just in case we needed it. And in fact, the guest who was originally going to talk tonight had to cancel, so we thought this would be a great time to show it. Now, although we're going to show you a recording of that evening, and you may have been there, Steve G0KYA is live, waiting for us now on the end of a Zoom call, and after the talk, which he gave at the school, we'll be going to him live. So if you have any questions or comments or anything for that, Steve will address those as well at the end. This is really wonderful software, by the way. If you've ever wanted to model an antenna, maybe you've designed an antenna and it works really well and you don't know why, or maybe you want to design an antenna, this is the sort of thing to use. And Steve gave a great talk at CNS. So we're going to play that without delay. It's just under an hour long, and then at the end we'll be going live over to Steve. So please ask your questions and make comments during the talk, and we'll relay them to him. Without further ado, here's Steve G0KYA with the talk on MMANA-GAL.
So tonight we're going to have a look at MMANA-GAL. You can pronounce it how you want, apparently. I'll tell you why it's called MMANA-GAL in a minute, and I'll tell you what it is. Basically, it's a program that lets you simulate, if you like, antennas. So you can design antennas, test them, and adjust them to get the gain that you want and the SWR that you want before you actually have to start cutting metal or wire to get it to work. I've been using it for now about 10 years or so. Okay, there are others available. There's 4NEC 2, there's EasyNEC, there's others, but this one does everything I want it to do, and it's completely free, which is always you know, a good word that we like as radio amateurs, isn't it? So let's have a look. We'll have a look. What I'm going to do is not so much concentrate on the program as what you can do with it. So we'll look at a number of antennas and what we can deduce from that. And then I'll talk about some of the things you can do with MMANA-GAL as we go through it. So first of all, why is it called MMANA-GAL? Well, it comes from the names of the people who designed it. Makoto Mori provided the MM, and then it's an antenna analyzer. So the AL comes from Alex, can't pronounce that, Shlulu, and the G comes from Igor Goncharenko. So there we go. What a mouthful. But that's where it comes from, MMANA-GAL. And as I said, it's a program, if you like, that models antennas for us. And it's free. It's based on the NEC, Numerical Electromagnetic Code Engine, which most of these actually are. But there's various types of NEC engine. And I think this is based on NEC 2 at first. And we're up to NEC 5, I think, or NEC 7, or NEC Pro 5 and Pro 7 versions 7, which are still free. But it was written in 1981. For the US Navy. And you think, why the US Navy? I'll show you why the US Navy in a minute. Now, the only thing that it's not good at doing is working with insulated wires. If anyone's designed any antennas that use insulated wires, you probably know that you end up with the antenna being a little bit shorter than you modeled it or you worked out, because the velocity factor of insulated PVC coated wire is different to a copper wire in free space. So MMANA-GAL is not terribly good at doing that, but you can make adjustments once you've finished, if you like. But EasyNEC now does do insulated wires with NEC 5. So if you really, really are bothered and you don't mind sticking your hand in your pocket, then you can buy NEC 5 or EasyNEC. I think EasyNEC is free now because the guy who wrote it is now retired, so he's given it away to the amateur population. But I'm not too sure how you got on with NEC 5 as well, whether you have to buy that. You used to have to buy a license, but we'll see. Anyway, we're going to concentrate on MMANA-GAL because it's completely free. So what does it feature? Well, you can create multi-element antenna designs and test them for performance and matching. You can have a look at the horizontal and vertical beam radiation patterns, generate 3D radiation patterns, now in color with version 3. And then you can do automatic antenna optimization. So you can say, right, this is my antenna, but I want it to have a better SWR, and you can press a button and it will actually adjust it until you get a low SWR. We might have a look at that later because it's a little bit complicated, but it can cause you to have problems if you're trying to do something really complex. But for simple antennas, it works fine. What else can we do? You can generate data files that can be offloaded and put into something else. So it's quite a powerful program. And as I said, we're on version 3 now. So I'll show you where you can get it from later. So version 3 is now fully compatible with Windows 7 and 64-bit systems. So that's Windows 10 and 11. The MiniNEC 3M core has been rewritten for improved accuracy. Toolbars extended. And then they've made a number of little changes to it. I said the biggest change I noticed, I've been playing with it the last couple of days, is that you get color graphics of the radiation patterns, which are quite pretty. But there we go. Okay. So this is what's new. This is actually what's new in version 3. So they've increased the number of segments. Now, what's the segments? Well, this works by breaking up the wires into little segments and then applying the RF to each segment, working out what the individual field is like from that segment, and then adding them all up. That's an easy way of saying what it does. It's a very complicated way of doing it, as we'll see in a minute. But so they've increased the number that can handle up to 10,000, which is way more than enough, and the number of wires. That is the number of elements to your antenna. It don't have to be wires. It could be aluminium if you want. That's been increased to 600. And the number of sources, the sources is like if you're applying your radio to a particular point, we call that a source. They've increased that to 100. I've never ever used more than one source, so quite why you need 100, I don't know, but there we go. And you can see the other elements that are in there as well. But it's an easy program to learn to use if you get your head around it. So what did we used to do years ago? Well, these are Maxwell's equations. Nothing to do with Maxwell House, but more to do with James Clerk Maxwell, who came up with some serious equations that how you handle electric and magnetic fields, enough to put the fear of God into any physics graduate or physics undergraduate, actually, because this thing is doing this for every segment, for every wire on the antenna, and coming up with the solutions, and then adding them all together. So what did we used to do? I mean, how did it used to work? Well, this is why I said this was produced for the US Navy. This was the US Navy's antenna test range in San Diego. And you can see in the middle there is a little model boat. And that model boat can be spun around. They can put antennas on it, and it can be spun around. And then up and down here, they can put an antenna to test. So by doing this and rotating it, they could plot out how the antenna was working from the model of the boat in the middle. So you can see why it was quite urgent that they came up with an easier way of doing this. I think that's brilliant, actually, but to have something like that in the back garden would cause hell, I think, but there we go. So this is why they developed an electronic way of doing it, and it's been developed over the years. So what do we use modeling for now? Well, you'd be surprised. I mean, this is something that I found. This is modeling the field strength and radiation in a head for when you're using your mobile phone. Now, the hotter the spot, the more radiation is being given. So you can see there that, with 8 watts there, we've got something like 8 watts per kilogram, which is enough, to be honest. But this is all done using modelling, and so this is one way of doing it. Or you want a more practical example. This is the magnitude of the electric field inside a microwave oven with a potato. And so what did the modelling result in? Well, it found that the potato cooks unevenly, the bottom cooks faster than the top, and there's a centre hotspot due to focusing in the microwave. And you can see on the left-hand pattern there, you can see why your food doesn't cook evenly unless it's rotating, because you've got all these hotspots. And if you don't believe me, break an egg into a microwave, then run it and see whether you get that kind of pattern. You probably will, unless you put it on a rotating dish. That was the trick for the microwave oven, to put a rotating plate in it. Otherwise, this is the sort of thing that happened. Anyway, we're not interested in microwave ovens. We're talking about antennas. So what do we need to know? Well, the three things you really need to know to deal with MMANA-GAL, just three things. That the antenna design is made up of straight wires. We use the term wires. They could be aluminium elements, but they're called wires. We also need to think about loads, which are traps, loading coils, made up of L and C components, so that's inductance and capacitance. And then we apply a source of a specific impedance at one point on one of the wires. So you need to know wires, loads, and source. They're the three things you need to know. So then, if we move on to MMANA-GAL itself, we can see how that works. So this is a 20-meter dipole, and you'll see we've got wires at the top, source down on the left, and loads on the right. So in this particular instance, we've got no load being used, there's no coils or capacitors, and we've got just one wire, which goes from minus 5.17 meters to 5.17 meters. So it's 10 meters long, so it's a half-wave dipole on 20 meters. And then the sources, we've got see where it says pulse, it says W1C, that means wire 1 central. And this is the way we use it. We said W, then the wire, and then you can put beginning, center, or end. So W1B would be apply the source at the beginning of W1, wire 1. W1E would be put it at the end. But we've got W1C, which is put the source in the middle of wire 1. Okay, and you can see also there we've got a frequency that we're aiming at of 14.05 megahertz. Once you start to use this, it makes more sense. But this is why I think get it right from the outside is that we use wires, and you can put as many wires as you want. And we have a source that we apply to the wires, and then capacitance and inductance, i.e. loads, we can also put that there as well. So this is the next section over, which is view. So we can look at the dipole, and you can see that we've got a dipole running across the screen there, the black one. And it uses the XYZ components. So X and Y are in the flat plane, and Z is usually the plane that goes upwards. So there we go. You can also see the current distribution on that wire. So we've got no current at the ends of a dipole, and we've got maximum current in the middle. So it's exactly what you get with a half-wave dipole. So good. So right, now we want to calculate. So we go to the next tab. There we go. And we say we're on frequency, 14.2 megahertz, I think it says there. We can add height to it, so we're going to put it at 20 meters. And then material, it said no loss there. You can put copper wire, you can have aluminium, steel, you put whatever. You can only have one material, so this for some reason I've put no loss there, which is silly. Should always have something in there like copper or aluminium. And then you just press the start button, and it will come up with a line. Take the top one there, line number 5. Every time you press the start button, it will generate a new line. So if you go and make an adjustment to the antenna and press start, you'll get a new line. So you can see it's adjusted for 14.35 megahertz. We've got an SWR of 1.75 to 1. And it's at 20 meters. So, right, okay, that's good. So now we can go to the next tab, which is far field plots. Oh, no, before we go there, I just want to show you something else. You can actually then go to plots on that screen and say, right, just graph me the SWR plot or the impedance plot or the gain plot. And so you get the typical sort of SWR curve that you would expect to see. So you can see that that's the lowest SWR is 14.15. So it's great. So we haven't had to cut any wire at all yet. We haven't had to go out in the rain. We haven't had to, get freezing cold. We've done it all on a computer, which is good. Right, so now we'll go to the plots, far field plots. And this is our 20-meter dipole. And as you can see, it's typical. The dipole here is running on the y-axis. So you get maximum radiation at 90 degrees to the dipole. And if we look at it from the side perspective, you'll see we've got the main lobes are about 15 degrees above the horizon. And then we've got these two other big lobes coming up. And as you adjust the antenna up and down, this lobe pattern will change. You don't just get what you would expect, which is just two lobes coming out the bottom. As you raise the antenna up, you might get other lobes break out. But it's a great way of doing it. And then we can go to the 3D view. And as I said, in version 3 now, this is in color, we'll see that later, but you can have a look at 3D, and you can rotate this around and have a look to see what you want. So you get a great idea of how this antenna is going to work before you even commit yourself to cutting wire, as I said. Oh, and you can adjust this so you can look at the vertical polarization elements to it, or the horizontal polarization elements, or you can look at the total field, which is what we're looking at there. So what about a typical example? Well, Roger, some time ago, I don't know if he still got it actually, he had a rhombic antenna, and massive thing. I remember going to Rogers and saying, oh, it looks like your neighbours are ham as well. He said, no, that's my tower. It was just way, way over in the next field. And I don't know if he's still got it, has he? I don't know if he's... No, I think it's taken down. But he said to me, why, he said, with my rhombic, he said, is it very easy to work kind of New York? He said, but you try and work Florida with it, and it doesn't want to know. And I said, well, okay, I'll model it for you. So all I need to know is the dimensions of the antenna, which is big, and what bearing it was on. So we came up with this plot here, which shows you why you couldn't work Florida. It misses it completely. So you can actually see that when you've got long antennas or big antennas, you may think you've got a tremendous gain, but it might not be in the directions you want. For example, in this instance, you'll see we've got these big nulls here. So all down the coast of America, you're either in that big lobe there, or you're in a null, which is not good. So just because you've put an antenna up, you can't say, oh, it's definitely going to work the way I want it to work, because you might have the places you want to work in a null. But the trouble with rhombics, of course, they're not easy to rotate, impossible to rotate. So this was put up specifically for to work on these particular places. So as a rhombic, excellent antenna, fantastic antenna, but only in two directions. Not very good for working Australia at all. Not for working New Zealand either. But if you want to work central US, it was absolutely fine. That's the sort of thing you can do with it. So let's have a look at some other antennas and see what MMANA-GAL tells us about them. Now this is a G5RV. I think does everyone know what a G5RV is? Yeah, very classic starter antenna really for HF. And everyone raves about them. Oh, I've got a G5RV, it's fantastic. Yeah, okay, well, what does this tell us? Well, if you run a G5RV, design and run a G5RV through MMANA-GAL, you find a few things. You see that it's got low SWRs on, fairly low SWR on 20 meters, which is the band it's actually designed for, actually. At 12 meters as well, it's below 3 to 1. If you look at 10 meters, it's 52 to 1. And even on 10 megahertz, 30 meters, it's 34 to 1. So it's not really a multi-band antenna, not a particularly good one. And anyone who's played with G5RVs will know that they're not brilliant performers on some bands, and in some bands you're going to cause problems. I managed to burn a ATU out trying to run one of these on 10 meters once. Well, this shows you why. But if you didn't model it and you just put the G5RV up, you'd never know. But this will let you play with things, as I said, before you actually start building them to see whether it works or not. And I think that the conclusion there is the G5RV is not really a very good multi-band antenna. So what about the ZS6BKW, which is like a G5RV, but it's shorter, but with a longer piece of 300 ohm ribbon or open wire feeder to it. Well, that's better. You can see there that we've got 10 meters is now 2.5 to 1. While 12 meters is 1.28 to 1. 21 megs, 15 meters, 80 to 1, not good at all. But 18 megs, 20 megs, 40 megs are all below 3 to 1. So it gives a better match across more bands. So if we put that in a little table, you can see what the difference is, or how they compare. So it's much better on 40, 20, 17, 12 and 10 meters. Better than a G5RV. And it's actually slightly shorter, but I think it's about another 15, 20 feet on the 300 ohm cable that goes to it. But there we go. That's a MMANA-GAL and what you can do with it. Right, what about the W3DZZ, which is a trap dipole? These are always being described as multi-band antennas, but in fact, if you do run them through a MMANA-GAL, you find that you've got a low SWR on 80 and 40, which is what it's designed for. Low SWR on 15 meters, 2.4 to 1. But everywhere else, it's not good at all. It's not going to, 11.3 to 1 on 10 meters, 35 to 1 on, is that 28 megs? Yeah, 35 to 1 there. I think it's meant to say 24 megs actually. 14 megs is not brilliant. So again, it's not really a good multi-band antenna. And I've played with this. I've tried different loading coils, different values of the capacitor in the loading coils, trying to find a combination that would give you low SWRs on all the bands, and basically gave up in the end. So the W3DZZ trap dipole works very well on 80 and 40, and then by design it kind of works quite well on 15 meters as well. But the rest of the bands, no, not good at all. Okay, what about, say, the magnetic loop antenna? Now, there's an awful lot been written about these over the years, but how do you design an antenna in a MMANA-GAL that's round? Well, you can't really. You've got to do it with straight lines. So we did an octagonal magnetic loop antenna like that. And so, okay, right, let's run it then. So this is the SWR plot. And as you can see, very, very sharp indeed. You'll get a low SWR, but only for within a very, very small bandwidth, which is exactly what you do find if you've ever played with a magnetic loop. They're very, very sharp tuning. But, okay, so what about, does the height above ground have any effect? So if you have the magnetic loop horizontal, this are the kind of patterns you get at 3, 12 and 24 meters. Now, I don't think you'll get a magnetic loop up to 24 meters, but it just shows you that the height above ground has a big effect. So you can see from 3 meters to 12 meters, it has quite an effect. It's far more efficient at 12 meters than it is at 3. And this is with the magnetic loop horizontal. It's not a good idea to have a magnetic loop horizontal unless you can get it at a fair height. And by fair height, I mean at least 10, 12 meters above ground. So again, we haven't had to do anything, but MMANA-GAL tells us that that's the case. So they recommend that with small magnetic loops that you put them vertical. So what about if we have it vertical then? So this is a same antenna, but now we've mounted it vertical and put it at 3 meters, 12 meters and 24 meters. And you'll notice that the difference between 3 and 12 is not that much. In other words, all the books say that if you're going to have a magnetic loop vertical, height above ground, doesn't have a massive effect unless you can get really, really high. So you're quite happy. This will work quite happily at about 2 meters, 3 meters above the ground. I've got one of these at about 2.5 meters, and it works quite well. What about the radiation pattern, though? I love it when you press a button and nothing works. There we go. So this shows you. I did this week. This is in MMANA-GAL 3. So now we've got these coloured radiation patterns. So you can see the hotter the colour, the more radiation there is coming off it. So you can see that You can just about see the green loop in there. So the radiation on a magnetic loop is in line with the loop. It's not off the sides, it's in line with the loop. So if you're going to have one of these, it's best to have it, if you can, on a rotator, so you can point it at where you want to work. Failing that, you've got to align the loop so that it's actually aligned with the country you want to work. And then you've got radiation in two directions, but off the side you don't get quite so much. So that's a magnetic loop, vertical rather than being horizontal. Now, W5GI is what we're going to use at Caister on 40 meters on Saturday, and this is a plot of what a W5GI looks like if it's flat. But what about if you do it as an inverted V, which is the way we run it at Caister? Is that the sort of radiation pattern you get? Well, no, not really, because what it happens is it squashes it down. So instead of having that kind of sort of butterfly type radiation pattern, you're now getting the black pattern, which isn't bad actually if you think about it. You're not getting those massive nulls. So if the station's in that null, you probably won't hear them, but now by making it an inverted V, you will. So looking at the pattern on the left, you can see the black area. It shows you that it's a much nicer pattern, more omnidirectional, if you like. There are no massive nulls there. But if you look on the right-hand side, you can see that you're down probably about maybe 7 dBs on those bottom lobes there. But that's the trouble with antennas; they're all compromised. So what is it you want? Do you want the maximum radiation in certain directions, in which case don't put it up as an inverted V, put it up as a flat antenna, or do you want to put it up as an inverted V and have it as more omnidirectional, but you do lose some of the gain from the antenna. So what's next? Microvert. No, this is an interesting little antenna. Has anyone come across the microvert? No? Google it. It's quite interesting. It's an antenna that's only about 1.5 feet long. It was designed by a German guy who has written all the instructions in German. And I actually said to him, he wrote a book about it as well. And I said, could I translate the book? And he went, no. I said, why not? He said, I don't want it translated. Well, okay. Right, that's it then. We'll call it a day. But I did manage to get some of the details translated, and I built a couple. And they're okay. But the big question mark with the microvert is it actually that little thing that's doing the radiation, or is it the coax that's doing the radiation? So if you model it, you get a pattern like this, which shows you can see the distribution there, that there is actually radiation coming off the coax as well. So whether the microvert is a fantastic antenna or whether it's the feed line doing the radiation, I think is interesting. It's probably why he didn't want me to translate his book. But yeah, it's interesting. They're interesting little antennas to play with. And I built one for 40 meters, and it wasn't as good as a dipole. And you can always tell, if you want, it's a good test this. Test your antenna and then lift the coax up and move the coax around. If the SWR changes, that's a good sign that the coax is actually doing radiating. And if you end up with a massive burn, RF burn, it definitely shows you that the coax is radiating. But I wouldn't recommend it. Hands up if you've ever had a radiation burn. You don't want too many of those. But there we go. Oh, and by the way, you can get a radiation burn with 10 watts, actually. You don't have to run masses of power. But if you run a linear, you'll definitely know you've got a radiation burn. Now, here's a little one. When I moved to my last house, I desperately put up a W3 EDP, sort of directional 85-foot wire with a counterpoise. And I just wanted to get something up quick just after we moved in. So I put it out the bottom window, threw it over the roof, and it went down the garden. But strangely, I found that I could work stations to the south, but that was about it. Couldn't really work much more. But putting it in a MMANA-GAL and playing with it shows you why. And this is the radiation pattern for that W3DP that I had. You'll see that there's quite a big radiation pattern to the south, southeast, southwest, and then a big null behind me to the north, And then there was a couple of little lobes out there to sort of, what would it be? It'd be the northeast and northwest. But by far the biggest radiation for this antenna was to the southeast and southwest. Also, it was pretty much a sky warmer as well. You can see this is on 20 meters, so not a terribly efficient antenna at all. But it didn't last long before I took it down and tried something else. But this is what I mean. You can take your design and put it into this and go, oh right, that's not going to work. Or how do I have to arrange this antenna in my garden to work what I want to work? Just because you've got two trees that are in the garden and you're going to string it between those two, fine, but you may find that your antenna doesn't work terribly well when you want to work America, say. You might be in a big null. So by doing this, you can at least see, right, okay, well that's not going to work, is it? So we have to play with it. So what we're going to be using on Saturday, on 20 meters and 15 meters at least, is a vertical end-fed half wave. Which is going to be up on the dunes, and it's perfectly omnidirectional. So we know that we're going to get signals coming in from north, south, east and west. It's perfectly, I think Roger said once, yes, it radiates equally poorly in all directions, which was not really fair. But you can see that that's the pattern we get, and then we've got a couple of lobes. So we're getting maximum radiation at about 20 degrees, and it works quite well. And it's dead easy to put up, and that's one of the main reasons, because it'll probably be raining on Saturday. We've done it in rain, gales. I don't think we've ever done it on a sunny day, have we? Well, we did, but oh yeah, I remembered now. Yes, you got stuck in the you don't want to be reminded of that. All right, the first time we did International Marconi Day, we had a problem. So you're going to use their flagpole. So that was the arrangement. We're going to use the flagpole, so it's great. So he hooked it up to the flagpole, pulled the wire, and the flagpole broke in half because it was rotten. So, now what are we going to do? So they had a cherry picker, didn't they? So David went up in the air on the cherry picker, and then what happened? I can't remember now. It stopped, didn't it? Yeah, it wouldn't come down again. So no. Yeah.
They didn't take any sympathy, but Kevin was very quick to get his camera out and take pictures of it. So
yeah,
that is exactly what happened.
And this was the first International Marconi Day we did. So great. So we're going to use a flagpole, and that's just broken in half. And now we've got him up on the... So I did say we could hold the antenna above your head for the next 7 hours. You'll be fine. But yeah. But this is why we use the end-fed half wave. It's dead easy to put up. It can put up the winds that we get at K-Stem. Boy, do we get winds at time. But there we go. So, yeah. That day, I'll never forget that, because I was thinking, this is not going well at all. But so we learned our lesson there. But this is another test you can do. This is an 80-meter off-center-fed dipole, or Wyndham, and as a flat top and inverted V. And you can see that as a flat top, you get low SWRs at 80 meters, 40 meters, 30 meters, 20 meters, 17 meters, 15 meters, and 10 meters. Absolutely fine. Brilliant. But if you do it as an inverted V, you suddenly find the whole thing shifts. So you no longer get a low SWR on 30 meters. These are all shifted down. You do get 50 meters come in. But where are we now? Yeah, so you get a low SWR at 26 megs, which is no use to man or beast, and you lose the 10-meter one. So just because you're putting an antenna up that the instructions say is really good, it may not be. So whether you're going to have it as an inverted V or a flat top, it's going to change how the antenna performs. So it's a nice idea to run this through MMANA-GAL to test, what is it going to do. How did I get that plot? I made it output the information to a spreadsheet and then graph the spreadsheet. Good. Likewise, if you have a 40-meter Wyndham antenna, off-center fed dipole, they will tell you in the books that you feed it at the 1/3 point. So you take the antenna, you work out the point which is 1/3 into the antenna, so you've got 1/3, 2/3. Bingo, that's where you feed it. Yeah, but if you do that, you get this idea. So it works on 40 meters, works on 20 meters, and works on 10 meters, but it doesn't work. It's got high SWR, maybe like 25 to 1, on 15 meters. So how could you change this antenna so that you can get more bands? Well, it's easy. You play with it on MMANA-GAL, and you find that if you feed it at the 41.1% feed point, now you've got it on 80, 20, 15, and 10. So by changing where you're feeding the off-center fed dipole, you can get more bands in. So that's another nice tip as well. So that's worth knowing, because if you're building an antenna and you've only got room for one, by doing this, now you can go on 15 meters as well. So I think that's another good way of using an antenna analyzer. Okay, so the 2 meter Slim Jim antenna. Who's heard of a Slim Jim? Who's got one? Yeah. Okay, so if we model a Slim Jim, you'll see this is the antenna you get. So it's omnidirectional, good. And you'll see it's got a very good low lobe here. Very low, just a few degrees. So that's why it works so well. I mean, it's got some higher angled stuff as well, as you can see. So that's not bad. And you'll notice at the side there, I've got 59 inches and 53 inches and 18 and 16. Why? Well, we built some of these some time ago in the club. And I did all the calculations, we worked it out, and we bought the 300 ohm ribbon cable. But when we put them all together, they were resonant on about 156 megahertz. And this is weird. I thought, well, why is that? Because I'd built some of them before. And we had used, originally we'd used the clear 300 ohm ribbon, you know, with a translucent plastic. And then we did the rest. We bought some black stuff. Well, the velocity factor of that was totally different to the white stuff. So it turns out that if you want to build one of these with white 300 ohm ribbon, then 59 inches is the length you need. But if you're using the black stuff, 53 inches is what you need. And likewise, the gap at the bottom, instead of 18 inches with the white 300 ohm ribbon, if you're using the black stuff, you use 16 inches. So again, you can play with these ideas to see, you know, what can you do, or how do you adjust the thing to get it to work. So yeah, so we ended up with these antennas that are on 156, and we had to, what did we do? Cut it longer or shorter? I can't remember now. To cut it to get it to 145 megs anyway, but there we go. But one good thing, I did wonder, what about 70 centimeters? Can you use a 2 meter Slim Jim on 70 centimeters? Well, if you run that through MMANA-GAL, you get this sort of thing. So you can, because you get low angle with on 70 sems with a 2 meter Slim Jim. So theoretically, therefore, it says it should work on 70 centimeters as well. So let's have another look at, this is a plot that I took with a VNA, and you'll see that this is 432 to 438, I think, and you'll notice it's below 1.67 to 1. So this was taken with a VNA, so this is actual results. So yes, with a 2 meter Slim Jim, you can use it on 70 centimeters. It won't be the most effective antenna in the world, because you are wasting some of your radiation is going up and out of the way. Good if you're using satellites, I guess, but it will work on 70 centimeters. So one antenna means you can work on 2 bands, although don't expect miracles out of it, but it will work on 70 sems. And again, playing with this like this, you can actually play with it and go, oh, right, okay, that does work after all. Right, so what are the pitfalls of using an antenna modeling program? Well, the software assumes your antenna has nothing around it. That is, if you've got, what should we say, metal greenhouses, well, not metal greenhouses, but metal framed greenhouses, that won't help. Loads of trees don't exactly help either. So you've got to, it assumes you've got nothing around it, but of course, in real life, you do have things around it. And if you've got too many antennas, Chris will tell you how you get interactions between them. You do. I remember we did a test one. Do you remember that? What was that damn thing we tried? Anyway, we couldn't. It didn't work terribly well, and we realised it's because there was an 80-metre dipole just above it, which screened it. Yep, we've tested so many things over the years. Yeah. What about the earth conductivity and dielectric constant? Do you know what they are? It comes with some standard ones, but if you are on a beach, say, that will make a big difference. Salt water makes a massive difference. Salt water works very, very well, but I often read people saying, oh, I'm right next to the river, that will work better. Well, it doesn't actually. Fresh water is not that good, nowhere near as good as salt water. It's fantastic. Make sure you use the right impedance. Often this program will default to 75 ohms, so I'll show you where you have to set that up and make sure it stays at 50 ohms if that's what you're trying to do. When I work on end-fed half-wave antennas, I set the impedance at 2,500 ohms, which is, if you do 49 to 1, think of using a 49 to 1 UNN, well, 49 times 50 gives you 2,450, so we have to do it with 2,450 to get the right SWR figures. Make sure you set the elevation you want to test, so it will come up with answers for the optimum elevation. But if you're thinking about we're building an antenna and we want to know how well it performs for DX, then you're going to have to adjust that and put, say, a figure of 10 degrees in or 5 degrees to get the figures you want. But so be careful of that, because it will come up with the answers for the best elevation, and maybe that's not what you want. You can model inverted V's, but you'll need Pythagoras to help you. Pythagoras' theorem to work out the length of the wire in terms of its XY coordinates. As I said, PVC coated wire will have to be shorter than predicted. About 90 to 95% of what you work out, it will be on here, is the actual figure you'll need to use. And real-life SWR values will be far better than predicted due to coax losses. For example, if you build an antenna and you measure the SWR at the feed point and then measure the SWR 100 feet away, you'll probably find the SWR appears to be better when you're 100 feet away on the coax. And that's just the losses in the coax make it look like you've got a low SWR. If you've got really naff SWR coax, like say RG58, well, if you put enough RG58 on any antenna, it will look like it's got a low SWR. But you're just heating the damn stuff. And finally, don't apply a source, the source in terms of MMANA-GAL, don't apply it to an angled joint. Put a short piece of straight wire in and feed that. There are times where if you try to do an inverted V with that little short piece in the middle, you'll get really weird results. I had an email exchange with a guy in Italy recently who said, I'm trying to design this multi-band dipole, but I'm getting really odd results. Where am I going wrong? And I said, well, that's probably this. So I remodeled it for him, and by putting little short pieces, sort of 2 inches long, that's all, and that cured it, and that was fine. And it says it's a simulation, so real life installations may not behave the way that a MMANA-GAL says it will behave, because of, you could, well, I was thinking in my house, up the garden, I found I had a car buried, literally a car buried with an engine in the garden. So that would make a big difference to your earth. And there we go. Yeah, oh, very good. Yes, thank you. So, as I said, you can buy a pro version of MMANA-GAL, but I really don't think you need it. It does the calculations faster. It can handle more segments, but 10,000 is more than enough, as is 10,000 wires. I think we've got 600 in the basic version of this one, and 10,000 segments. That's fine. I don't think you really need to do, to buy the pro version of this, unless you're doing things like this. This was a parabolic antenna that has been produced in MMANA-GAL Pro. I just dread to think about how long that took them to do that. But if that's the sort of thing you're trying to model, then yeah, you probably need a better program than MMANA-GAL Basic. But otherwise, MMANA-GAL itself is fine. So where do you get this damn program from? I'll leave this slide up for a little while so that you can write it down if need be. I find if you search for MMANA-GAL, you might go round and round in circles trying to find it, but this one that I've highlighted in blue is the one that actually works. There's quick start tutorials on the web as well, and there are YouTube programs. I mean, the presentation I'm giving here, I've given this before. It's on YouTube as well. But DX Commander, you know, the guy who does the verticals, he has done a YouTube one on easy antenna modeling with MMANA-GAL. A lot of people say to me, I just can't get my head around how to use it. Just break it down, start off with something simple like a dipole, and then work on that from there, and you know, get to know how it works, and then you can start adding more elements to it or trying to work with beams. But there we go. And there are many more tutorials. If you just search for MMANA-GAL on the web, you'll find all sorts of things. And then just penultimately now, just one thing. It's only a model. So no one got DXCC using MMANA-GAL. So, you know, you can model your antennas till you're blue in the face, but until you actually build them, you won't know how well they really work for you. So, but I think it's a good tool to use. It's a good tool to get to know how to use, so you can at least play with it and see how things will work. If you've got a specific sized garden, you know, what's the best antenna for working America from my garden? Well, it may not be the one you think it is, but there we go. And finally, big plug, just to say, there's a book available from the RSGB. Not too much money now. It's an introduction to antenna modeling. It comes with a CD with instructions on there, and it comes with CDs with lots of models of antennas you can play with and play yourself. But what I've done tonight is, if you go to, let's go back to the first slide anyway. Where are we? Right. If you go to qsl.net G0KYA, that's not right, I don't think. Actually, if you go to G0KYA.blogspot.com, that would work better, I think, for you. So G0KYA, or just Google G0KYA. If you get onto the Blogspot site and search for MMANA-GAL on there, one of the stories on there, or the posts on there, has a link so that you can download all the antenna definition files that I've used tonight. So it comes included with the book. It's not a free book, the book from RSGB. But for tonight, I thought, well, I'll put them up as we're talking about it. You can at least download them, so you don't have to design G5RVs. You don't have to design, you know, verticals and you know, bits and pieces. They're all there. So if you go to, I said, Google G0KYA, it's the Blogspot site. Just look on there and go to MMANA-GAL, and you'll find a link to download the as a zip file with about 20, I think, antenna definition files that you can play with. So there we go. At this point, any questions? If not, I'll show. We'll do a quick demo of MMANA-GAL. A little stunned look.
Yeah. Any questions from anybody? I hate to say this, I shouldn't really say this, Steve, but I happened to be on the Monday Night Net this week, and someone said they were looking forward to this, and they were going to buy your book, but it's out of stock currently at the RSGB. I don't know if you knew that. So
I didn't know that.
But it will come back. I'm sure it's just out of print temporarily. So,
okay.
So hold on for that. Anybody got any questions right now? Yeah.
Yeah, just done something on segmentation. How do you choose the right segmentation length or number of segments?
I generally let it do it itself. Does auto segmentation. That seems to work quite well. You can, I'm trying to remember which way it is now actually, but you can, if you want, say I want more segments. Yeah, auto segmentation, that's what I've got. You can make it so that it segments more, which will give you a slightly more defined radiation pattern, but I just leave it on automatic. I've never felt the need to do anything other than that, to be honest. So anyway, does that answer your question? Probably not.
Yeah, I mean, I use it on auto and on choose my own, but you get different results.
Do you?
So you need a correction if you use auto segmentation compared to a higher number of segments.
Right. Okay, that's interesting. You shouldn't really get that. That should be the same. But are they massively different?
Well, at VHF it's about 3 millimeters.
Yeah.
Yep.
Yeah. Okay. Yeah, that makes sense. So that's okay. Let's just play with this now. So let's put a 20 meter dipole in. Ooh, God, I can't even spell dipole. It's always a good idea to name these things so that when you look at them, you can find out what it is. So let's say 20 meter dipole would be what, roughly 10 meters long, half-wave dipole, yeah? So if we do -5 there, and we go to 5 there, right, so we've just got a piece of wire that's now 10 meters long. So I'm going to feed it in the middle, so that's wire 1 central. No loading coils, nothing like that. So let's have a look what we've done. So there it is, and so you can see we've got the feed point, the source, as it were, in the middle, and you can rotate this around. So good. Let's have a look at calculate now. So material, we're going to make copper wire. There we go. And I'm going to put it at 10 meters. Good. And then run it. So there we go. We've got a 20 meter dipole, which I've only cut to 10 meters long, with an SWR of just under 3:1. So if we look at plots now, say, okay, show me the SWR plot, details. There we go. So we can see that the antenna is actually resonant above 14 megs. So it's, yeah, it's too short. Okay. So somebody was saying earlier, how can you use the optimization? Well, okay, let's have a look. So optimization, you basically decide what it is you're trying to optimize. So we want a lower SWR. So I'm going to put that as one of our, just got to put the mic down actually. We're going to put that as the thing we want to do. Hold on. There we go. So the SWR is what we're trying to optimize. I'm not too bothered about the gain, front to back, or the elevation. So let's knock those down. Okay, and right. And we're going to do it on wire 1, which is, we have only got one wire, so that's it. So right, start. So now it will go away and it will play until it actually gets the lowest SWR it can on 0.15. So if we now look at the thing, you'll see that it's now, what is it now? It's now at 2.9. That shouldn't be like that. Okay. Let's have a look at the plots now. Detailed. There we go. So now you can see that that's the SWR plot we want. And so it's optimized it for SWR. We can optimize for gain, you can optimize for impedance, you can optimize for what you want. Not the easiest way to do it, but it saves playing with a calculator. But obviously, if you were building this for home, out of PVC covered wire, I would take this length that it's calculated and I would multiply it by 0.95 to make it slightly shorter, and you'll find that that will probably be it, because it doesn't know that PVC coated wire has a lower velocity factor than copper wire. But the more modern and more expensive versions of EasyNet can do it, but it's not too bad if you just remember that from the outset, that that's the way you have to do it. So that's how you can optimize something. But it's got its limitations. If you've got a 4-element beam and you want to optimize that for SWR, and you say, right, well, optimize element 1, element 2, element 3, element 4. So it can adjust the lengths of the beam and it can adjust the inter-element spacing. That's a lot of work to do. So maybe you'll find it will churn around forever and may not give you the right results. So I think optimization is best used for simple antennas, but anything more complex than that, you probably go around in circles trying to get it. We tried this once. Roger wanted to know how we could get a better signal out for the 80-meter club championship. So we were looking at reflectors under the dipole, and worked out eventually that something about a foot off the ground and longer than the dipole would do it. But I don't think we ever tried it, to be honest, but it was the only way we could get it to have maximum gain or increase the gain in a north, skyward direction. But so that's a basic, figure, a basic antenna, 20-meter dipole. So, let's have a look at the far field plots then. What do we see? There we go. So, at that kind of height, you'll see that. I'm just going to adjust this a bit because I don't think that should be 0. Silly thing. That's it. All right, run it. Yeah, hang on. Well, this is at 10 meters. So you'll notice that we've got, quite a high lobe there, not terribly good. And this is 10 meters with real earth underneath it. So we're going to put it up to 20 meters now. And run it. Interesting. So you'll see that if the antenna is running across there, it's still maximum radiation is broadside to the antenna, absolutely. But not the sort of polar pattern you expected, I don't think, is it? Let's have a look in 3D, see what it looks like. So there we go. Yeah, so this 20-meter dipole at 20 meters, you actually get 2 lobes coming out. So you've got a low angle lobe and you've got a high angle lobe as well. Probably didn't expect that, did you? Okay, so let's put it up higher, even more. Calculate. 30 meters, so we're getting up there now. Start. All right, far field. Oh, well, worse, yeah, great. Okay, let's put it down to 5 meters then. So it's a sky warmer now. So you can play with this to your heart's content. 50 meters. It's a lot easier than buying a house and a tower, I tell you. Right. Yeah, interesting, isn't it? So yeah, we can model anything. So what have we got here? Something I've been playing with is an end-fed half-wave multiband. So this is an antenna with 2 traps in it. Now the traps are fairly easy to put in. You see we've got wire 1 at the end. We've got LC trap there. So we've got 0.627, I think it's microhenries, and 51 picofarad capacitor. So it's a trap with a LC element to it. And then we've got another trap on wire 6. So we end up with a vertical with 2 traps in it. And so we can play with that now, and there we go. Let's run it on 20 meters. So there we go. That's the sort of plot you get. So again, omnidirectional and fairly low radiation angle. There we are. So that's for 20 meters, and if we do it for 15 and 10, we get similar patterns. The only problem is with this antenna design is that, and we may use it on Saturday, I'll see, is that unfortunately, if you have an antenna that's got a trap there and a trap there, obviously if we're running this on 20 meters, maximum radiation is right in the middle of that. Let's run it now, I'll show you. Maximum radiation is right where that trap is. I'll just put the currents up so you can see. There we go. So you can see the maximum radiation point is right where the trap is for 10 meters. So this is why it doesn't work terribly well on 10, I don't think. But again, you can play with this and you start to see, you can build a 3-band end-fed half-wave trapped vertical, but you've got to bear in mind that what I just said is that a lot of the current is going to be in that trap. So it doesn't really help. But you do end up with an omnidirectional antenna with fairly low angular radiation. And I haven't had to build anything, so there we go. Yes?
I'm going to poke holes in it. The 10-metre trap
Yep.
at 20 metres ought to be almost invisible.
You think so?
Yeah.
Well,
Well, that'd just be a little bit of a coil, wouldn't it? I mean,
it'll be a coil.
and at 10 metres, it should be basically an open circuit. So all your current will be at the bottom. That's the problem with it.
well,
Because it'll only be a 2.5 metre tall antenna at the ground, won't it, at 10 metres?
no, we're not talking about quarter waves. We're talking about half waves.
All right, half wave, all right, be 5 metres tall.
Yeah, and there's the maximum current.
That's on 20 metres.
This is on 20 metres, and there's the 10 metre
10 metre trap, yes.
So,
But that
yeah.
should be almost invisible to the 20 metre signal, shouldn't it?
I don't think so, if you think about it.
Well, that's the whole point of it, isn't it?
Yeah,
It's
it's-
supposed to have
well-
very low impedance at 20 metres.
Yeah, but it's still current going through a
Oh,
coil.
there is current going through it. It will-
Yeah. So it's current going through a coil. So
Well, that's why you got that little kink in the...
yeah,
Well,
yeah,
I think I can see a kink. Should have brought my glasses.
yeah. Anyway, that's not.
So if you do the plot for 10 metres, that should stop there, shouldn't it?
yeah, 10 metres isn't so bad.
But it's just not very far off the ground.
No. There we go. 28.5. As I said, I will probably bring this on Saturday, but we won't use it on 20 metres because I find in reality. Whoops, hang on. There we go. You can see. That's kind of, there is some bypass up through the trap, but yeah, it still gives you a low SWR. But I found comparing it with a full-size end-fed half-wave that it's down a couple of S points, and I think it's why, because the current in the trap. But
What, you just think the trap is a bit lossy?
yeah,
Yeah.
yeah.
Will it handle 200 watts, Steve?
I don't know. We'll find out. I think it will. The traps, these traps are designed for 400 watts, so they will take it. Yeah. The matching box might not, but we'll see. But if Andy melts it, we'll know. Right.
There we are. That was, we mentioned earlier, in case you joined us later after NARC Live started, that was a recording of Steve's talk that was given earlier in the year at CNS in April. And the thing he kept talking about, by the way, for Saturday was the Caister Lifeboat Weekend. Anyway, I'm going to go straight over now to Steve because he's here live and he's ready to answer your questions and queries and add anything else that I guess he's thought of to the talk. Hello, Steve.
Hello, how are you?
I'm good, thank you. Thanks very much for joining us tonight.
It's actually quite weird watching that. I can't even remember saying any of those things.
I must admit, no, even some of it I didn't really remember, but then I guess we both do quite a lot of these things, and maybe that's why. But anyway, it says it's really good of you to join us again after this, and I hope that we'll get some questions and comments and feedback from everybody watching this tonight. We've still got tonight, even though quite a lot of people, 30, 40 people watching live, so which is quite a lot really, considering we gave this talk at the club. So this is your opportunity at home. If you've got any questions or anything about MMANA-GAL, or I guess anything else about antenna modelling you'd like to ask Steve, then this is a great opportunity to do it. I'm going to kick off, Steve, with one thing, a bit of feedback really from John G0KYA, who says that excellent book on antenna modelling is still out of stock at the RSGB. I know we're not blaming you, but do you know, yes, I was going to say we're both going to see the man probably is responsible or can do something about it at the weekend, but have you any idea roughly when it's going to be back in print?
I have no idea. We'll kick him on Saturday.
Well, maybe not physically, but yeah, I know what you mean.
I think we will kick him.
Okay. I'm not going to name him in anyway. All right. Well, yes, sure, we will. John, thanks for feeding that back, because obviously it's quite a long time now, from April to October, not to have that book in stock. And I'm sure the man at the RSGB who's dealing with this will take note. Hopefully some of you. So some questions. I mean, looking back at that though, Steve, actually, and obviously it is a bit weird looking back at something you've done like that. Is there anything you'd like to add or anything you'd change now or anything maybe that you've learnt since giving that talk?
No, I don't think so. I think it was fairly comprehensive. I think the problem with MMANA-GAL is that everyone's got a different antenna they want to model. And so the techniques for modeling it are going to change from person to person. But I think the only thing you can do is just, as I said, start with something simple, like a dipole, and then work from that. If you just go straight into it to build a, I don't know, 15 element beam, you'll get stuck.
I mean, we've done lots of these talks together now over the last few years, and I'm still fascinated to think. Do you think there are still brand new antenna ideas to model? Obviously, you don't know them, or you'd be doing them. But I mean, in other words, is there a lot to discover yet? Do you think about antennas? And would this software, where I'm leading to, would this software help you test those ideas and develop those ideas?
Oh, that's a good question. I don't think that there's anything brand new going to come out of anywhere. But there's innovative ideas that people have to make things smaller or more compact. But the rules of the antenna don't change in a way, and Maxwell's equations don't change. So I don't think we're going to get any massive surprises. I mean, over the years, we've seen crossfield antennas, we've seen EH antennas, and yes, they all kind of work-ish, to an extent. But I don't think it's going to be anything new. But the problem is with some antennas that you can't really model them with MMANA-GAL. I mean, the W5GI is a very difficult antenna to model because of what it's got in it. It's wire and coax, so you can't really model coax in MMANA-GAL. You can kind of make a kind of model of what the coax might look like, but it's not going to be accurate. That's the trouble. I don't think it answers your question, does it, really?
Well, no, not really. So it was just an exploratory, really, question. We get used to technology and the electronics of radios, things getting better and better, software probably changing the way that radios are designed now from years ago that maybe we wouldn't have foreseen, say, 20 years ago. And I just wonder, with antennas, which we're always telling people is still things that you can make yourself, I mean, are there, just wondered if you thought there might be new things to discover. I mean, think of, for example, of DX Commander, Callum, he seems to have created some, at least new variations on traditional antennas and the way that he deals with things like radials and things. I haven't studied them in detail, but this is just things I hear from people who buy his antennas and find them a little bit better than some of the traditional antennas they're based on.
What DX Commander has done is create a multi-band vertical, which is basically a series of quarter wave elements, all fed from a common feed point at the base. The clever thing that he's done is he's played with it and played with the lengths of them to get the lowest SWR without too much interaction between all the elements. And some have had to be made longer, some have been made shorter. And then once he's got the lengths correct, make a good note of them and sell it. So I don't think he's invented anything. He's just adapted an idea from old ideas. So as I said, it's basically a multi-band quarter wave vertical with a common feed point, and the elements to it are spaced apart by a couple of inches. But he's had to play with the lengths to get the thing to resonate where he wanted it to. I'm sure when he first started, he found that if he added a 20-meter element to it, and then he found that probably messed up the SWR on 15 or 10. So he had to play with those again. So lots and lots of iterations to get it right. But yeah, I don't think there's anything new in the antenna game. The only thoughts I've ever had have been, well, okay, should we try covering this antenna with liquid nitrogen or liquid oxygen and really super cool it, whether that would work. But the trouble with HF antennas, they're so big, it'd be very difficult to ultra cool them.
Would you be doing that for zero loss sort of thing?
Yeah.
Superconductivity, basically.
Yeah.
Okay. Wow, interesting idea.
I don't know. Maybe taking an EH antenna, which is a much, much smaller antenna, and filling that with liquid nitrogen, see what would happen.
Well, there's an idea. We'll see if someone tries it. No, it is a lot of the case, of course, that lots of ideas are not new. They're just things that are refreshed and different approaches to them. But it'll be interesting to see. We've got a couple of questions anyway from Graham, G8NWC, who says, great talk. How do you put in elevated radials for verticals?
Well, that's fairly simple. I mean, you just make sure that the antenna is off the ground to start with, and then connect the radials up to the base of the antenna and feed it at the base. So elevated radials are fine. They're not a problem at all. Ground-mounted radials are harder with MMANA-GAL because it doesn't model the ground terribly well. But elevated radials, yeah, just design the whole thing in the air, 1 meter above the ground or whatever, and then feed it at the bottom. So yeah, it's not a problem making elevated radials. The only thing with elevated radials, by the way, they have to be resonant. Where if they're on the ground, they detune, so they don't really have to be resonant.
Okay, Graham, I hope that's helped you. Thanks for the question. Malcolm G3PDH says, would be interested if it could model the Step IR urban beam, bow tie shape, but he says he'll also try and chat to you at the weekend about it. Any thoughts on that?
Yeah, that's an interesting shape, isn't it, a bow tie? And the Step IR, presumably it has the elements that are extended into the bow tie. So I think you could make a half-hearted attempt at it using straight lines. But yeah, we'll chat about that at the weekend. That sounds good. As I said, the magnetic loop, you can't do circles with MMANA-GAL, but you can certainly make an octagonal one, which is near enough.
Yeah. This software, is it pretty unique? And there is not much to choose from. I mean, unlike say logging software, there's lots of choices there, even though people have their favourites. But this software, from the things you've said before about it, just seems to make it fairly unique, and especially when it's free for amateurs.
Well, a few years ago, EasyNet is its biggest. Well, I wouldn't say competitor. I think EasyNet is better than MMANA-GAL, but you had to pay for it. But as I said, now that the chap who designed EasyNet has retired, I think he's made it freely available to the public. The only difference I would say is that if you train yourself on MMANA-GAL, then move to EasyNet, you'll probably have problems with it because it works in a slightly different way, or vice versa. If you're used to using EasyNet and then you move to MMANA-GAL, you've got to get your head around how to do it. So it's best to stick with one and learn one. And I think MMANA-GAL is probably one of the easiest ones to learn, which is why I stuck with it and obviously came up with the book.
Yeah,
but
absolutely. The book that you can't get, but we're going to put pressure on.
Book that you can't get, yes.
John has come back and said he definitely wants one, so there's at least one sold. I'm sure the company's trying to print one, but
I would say try Amazon as well, because I think they have a slightly different source for getting them from Amazon, so it might be on Amazon.
Okay, that's an RSGB published book, isn't it?
Yeah.
Yeah. Okay, but we will have a word with the man.
We will have a word with the man.
All right.
Yes, yeah. You hold him, I'll hit him.
Ralph, it's getting racy, this, isn't it? Ralph 2M0RHT. By the way, he did complain a little bit, gently complained that he couldn't hear some of the sound of. This is one of the things, Ralph, I should explain. I'm sure everybody realises that was recorded at the school, but recording an event like that is quite difficult, and especially miking the audience as well. It's almost impossible when the people like the BBC make it look so easy on things like Question Time. They've got people with boom mics, and there's lots of little cuts done as well in it. We were doing that all as live, or doing it live, in fact, really. And so that's why. So I'm sorry if you couldn't hear all of it, but it is one of the challenges of making television programs like that and recording them and then replaying them and getting the sound right. And I'm sure also, by the way, Ralph, you'll understand that, Steve was both holding a mic and using a computer at the same time to show things on the screen. So quite tricky, but it was an experiment. And I think it went quite well. Hopefully it allowed lots of you who couldn't make it to CNS that time to see. Anyway, Ralph's come back and asked a question here. Does the metal used in an antenna make a difference to transmission, i.e. steel versus aluminium?
Yeah, it's all down to the conductivity of the metal that's used in the antenna. So copper would be probably the best, or silver is very conductive. Aluminium is a close. I suppose it's a close. What's the word I'm looking for? It's a good substitute for copper.
Comparable, I guess, maybe.
Yeah, well, it's a lot lighter, and its conductivity is probably about as good. I can't remember the conductivity of all these different metals, but if you look them up, you'll probably find that, as I said, gold would probably be the best, and silver would be better. But I think if you made all your antennas out of silver pipe, you'd bankrupt yourself. So, and aluminium soon degrades if it's left. It just oxidizes. So aluminium oxidizes as well, but it's a much lighter material. So I think that's why. But yes, so yes, you want to get the conductivity as high as possible with your metals. Yeah, so steel's not good, really.
No, I mean, you might see some cheaper cables now in recent years when copper's been so expensive. Ralph, you know, a lot of cables now, they'll say things like CCA, which stands for copper covered aluminium. So they use it in cables because it is cheaper. Not because it's lighter, I'm sure, but not maybe quite as good as copper. Most of us, I think, would agree, and very difficult to solder as well, incidentally, as well. I think we've almost had done with the questions there, so unless you've got anything else, put them on really quickly now. Graham's come back and said lots to play with, been discussing radials and folded radials with some people. Thanks, he says, and see you at the weekend. Graham Ball, who will be part of the RSGB team as well.
Oh,
at
yes.
the convention. I think that is it. Thank you very much indeed for joining us again, Steve, and reliving all of that talk. And really, it's always good to have you on board. Talking about antennas, your expertise and your experience is really helpful to our members. So thanks once again, and I look forward to seeing you as well at the weekend at the RSGB convention. Thanks a lot, Steve.
See you in Milton Keynes.
Thank you. There we are. And that was Steve, G0KYA, our member, of course, and it was very nice for him to join us again. And thanks for your questions and feedback, and hopefully you find that useful. That is about it for tonight. Just to remind you what's coming up this week, we've got the GB2RS News as usual at 7 o'clock on GB3MB on Sunday night. On Monday night, the Monday Night Net at 7:30, also on GB3MB. And the next Wednesday, October the 16th, we're at CNS for an in-person meeting, an informal and social. Plus, of course, we've got that show and share table as well. We hope to see lots of you then. Don't forget to please keep us up to date with some stories, your pictures and things as well, which we can use on the next NARC Live when we see you again in another 2 weeks' time. But until then, from Tammy M0TC.
Bye-bye.
And from me, David G7URP. Take care of yourselves, look after each other. Bye-bye.